In this video, we're going to look at how to simplify rational expressions. So we can simplify rational expressions by factoring the numerator and the denominator and then dividing out any common factors. Let's look at this example. If we let f of x be equal to x squared plus 3x over x squared minus 9, the first step we would take in trying to simplify would be to factor both the numerator and the denominator. Well, in the numerator, we can see we've got a common factor of x, so we can common factor that x out. And in the denominator, notice that we have a difference of squares, so we could factor that as a difference of squares. Therefore, the next line down would look like this. Common factoring out the x from the numerator, we get x times x plus 3. Factoring the denominator as a difference of squares, we get that. Now, notice that we have a common factor here. X plus 3, this binomial, exists in both the numerator and the denominator. Also notice that both the numerator and the denominator are fully factored. They're written as a product, in other words, everything is being multiplied together, and there's nothing else hanging on being added or subtracted at the end. There are no exposed plus or minuses that are not within brackets, so they're fully factored. Because of that, we can cancel out this x plus 3 that is common to both the numerator and the denominator. Once we do that, our simplified form is what's left over, x over x minus 3. So we've simplified this original rational expression to this simpler rational expression by factoring and then canceling the common factor. Now, remember that we said that with rational expressions, we have to be careful of restrictions, and we looked at how to do that in an earlier video. Now, in order to find the restrictions on this rational expression, we need to consider the denominator at this step. So we cannot have the denominator be equal to 0, and we need to place restrictions on the domain of the function, or the values that x can take, in other words. Again, to do that, we're going to take a look at this step. At this step, we've factored the denominator. We factored the numerator as well. We factored the denominator, but we haven't canceled anything yet. And that's the step we want to look at to find our restrictions. We want to find anything that would make this denominator equal to 0. Now, notice we've got two parts to this denominator, the x minus 3 part and the x plus 3 part. If either one of these parts was equal to 0, it wouldn't matter what the other part was equal to, because 0 times anything is 0. So if either one of these parts was equal to 0, the whole denominator would become 0. So let's take a look at what would make each part 0. Well, in the x minus 3 part, for that to be equal to 0, solving for x would have to be equal to 3. So we want to outlaw that, so we place the restriction that x cannot be equal to 3, and that would be our first restriction. In this second part, for x plus 3 to be equal to 0, again, solving for x, we get that x would have to be equal to negative 3. We don't want to allow that, so we restrict that x cannot be equal to negative 3. So those are our two restrictions on the function, and we found them by looking at the factored uncancelled denominator. X cannot be equal to 3, and x cannot be equal to negative 3. Let's look at another example. So, question says, simplify and state any restrictions on the domain, or any restrictions on x. Again, we have to factor the numerator, factor the denominator, and then cancel. Now, these are slightly more complicated factoring problems, so I'd suggest you pause the video now and then try and do the factoring and the canceling yourself, and then you can check your answer. So pause the video now, try and complete this question, factor, cancel, state the restrictions, and then we'll go through the answer. Okay, if you've tried that now, let's take a look. The numerator would factor to x minus 2 times x plus 1, and the denominator to 2x minus 1 times x plus 1. We could cancel the x plus 1s now and get that. This is the step where we have a factored but uncancelled denominator, so we need to look at what would make that equal to 0. And we get x cannot be equal to a half or negative 1. And I've shown you here why that is. The half comes from this part, the negative 1 from the other.